So this is an audio reactive lighting system thing that I put together, and what this device box here is just a switch that turns itself on or off based on whether there is an audio signal going in this jack here or not. So you can set it either to turn on when there is an audio signal and off when there isn't. Or off when there is an audio signal and on when there isn't. And that's controlled by this switch here. And there's also a couple of knobs, and the orange knob is gain control, so that obviously has to be adjusted according to the kind of audio signal that you're plugging in. So obviously if you plug in a guitar or a microphone or something else, it's an instrument level signal, then the gain would have to be set quite a bit higher than if you were plugging in say a line level signal. And also the gain, the optimal gain setting can be different for different guitar sounds. So for a distorted sound you might want to set the gain a little lower than for a clean sound. And the green knob is what I like to call the flicker knob. So the flicker knob basically controls the amount of time that the switch waits before coming on again after turning off, or the amount of time it waits before turning off again after coming on. So with a low flicker setting, say if you were doing a fast picking kind of thing on guitar, then the light would just stay on. Versus if you had a high flicker setting, then what would happen is that you would get a lot of flicker. The light would flicker a lot. Right, so obviously the audio signal goes in there, and this is how you introduce the switch into your lamp circuit. So you use something like this. Here we go. So this is basically a cable thing, something like that. This goes into the wall, and then your lamp plugs in over there, and in the middle there's this other plug which is in the middle of the circuit, and that plugs in here. Now there's a bit of a problem here which I didn't sort of anticipate, or well, I didn't think about it. But if I plug this in first, then one of these has a live voltage on it, so that's a bit dangerous. So you want to plug this in first and then plug this into the wall. So the main component in this circuit is this thing. So this is a solid state relay module based on this let's see if this is going to focus, G3MB-202P optocoupler made by Omron, and these are basically marketed for use with Arduino. So on this side what you have is you have DC power in, and you have a trigger, and the trigger is a low level trigger. So what that means is that the relay actually comes on when the input into the trigger channel, marked CH1 over there, when that is low voltage and not when it is high voltage. So that obviously has to be considered while designing a circuit for it. And on this side you just have the switch. The circuit of this itself is quite simple. I'm just taking the audio signal in here and amplifying the positive half of it, smoothing it out by an adjustable amount, which is this flicker knob, and then feeding it in to the relay module through a system of transistors which allow me to change the mode. I'll put a schematic up for this, and I'll put the link in the description probably, maybe with a link to a list of parts or whatever, I don't know, I haven't figured that out yet. But and also I've used a non-inverting amplifier circuit on the input, and that is because basically that has essentially infinite input resistance, or input impedance I should say. And what that means is that if you use one of these things, so this is just an audio splitter, which is just, you know, a male audio jack on this side and two female ones on this side, and it's just all connected together. So you can use this to split an audio signal from an audio source, and then, you know, plug one of them into your PA or your amp and the other one into this, and basically the presence of this will not make any kind of significant difference to the overall input impedance or the load on your audio source. And if you use this with a guitar, you would want to use it after effects, or after an effects pedal, at least a buffer of some sort, because otherwise, since there's mains on this side of this circuit, you're actually going to get noise that travels down the audio cable and makes its way into your sound. So you wouldn't want to do that. So you'd want to put this after a buffer or a distortion pedal or something like that. Yeah, so this was fun. I had fun playing with this. That's about it.